Okay, here's an integral that can be evaluated using the properties of trig functions. So we need two things. We need to know the derivative of tangent, and we need to know a certain trig identity. So if we'll recall, the derivative of tangent is secant squared x, and then we also know that tangent squared x plus 1 equals secant squared x. So that should provide some motivation for a substitution. So we have secant to the fourth x. We can save one of the secant squareds and rewrite it as, and use it for a substitution, and use the other one to rewrite as tangent. Okay, so let's see how that works. So we'll rewrite the integral as tangent squared x times secant squared x times another secant squared x dx. So let's group the final secant squared x dx together. Now we can write this middle secant squared x dx, secant squared x using the trig identity. So that'll give us tangent squared x times 1 plus tangent squared x times secant squared x dx. And now we're all set for a substitution. So we'll go ahead and let u equal tangent of x, which will make du equal secant squared x dx. So let's see what that does to the integrand. So here we have all of this bit is du, and then we have u squared times 1 plus u squared. So that leaves us with an integral of a polynomial function. So let's see it happen. So here we'll have, so I'll distribute, we have u squared plus u to the fourth du, which can be integrated to 1/3 u cubed plus 1/5 u to the fifth plus a constant of integration, which we can finish off with our original substitution. So that gives us 1/3 tangent cubed x plus 1/5 tangent to the fifth x plus our constant of integration, and that is the final answer.